Okay, the lesson for today is 13.4, translations, on page 44, section 13.4, translations, page 44. You don't have to worry about your heading because you already have a foldable done. Just fold that top piece over and you can write translations across the top there. Remember, this is section 13.4. All right, and we're on page 44. Page 44. Okay, if you look at page 729, it starts off talking about what a transformation is, and that's what we're working on in this entire chapter is transformations and how different polygons can move and turn and change sizes and how we can still know what their coordinates are based on those. So if we take a look at page 729, it says, a transformation is a change made to the location or to the size of a figure. We need to write that under transformation. It's a change made to the location or the size of a figure. And when they're talking about the figure, they're talking about a shape of some sort. Either you've made it up or they've given it to you. Okay, and then once I get that new figure, once I've moved it or once I've changed its sides or once I've rearranged it, that is called an image. This is the new figure once you've applied your transformation. Now, to show that, they use prime notation. They use prime notation, and it says prime notation is used to identify the image of point A. You read A prime as A prime, meaning like if I have A, this is the old image, and if I have A with that little apostrophe, this is the new image, and it's read A prime. You can have A double prime, that would mean 2 apostrophes. You could have A triple prime, that would be A with 3 apostrophes. Now, in this book, they use blue and red to help recognize our old figure and our new figure. So I also want you to write that here as well, that the blue is the old and the red is the new. And I guess it shows example of prime notation there. So A prime or B prime. Okay, we could have a double prime. Any of those are prime notation. All right, so our first type of transformation that we're going to talk about is our translation, and that's what we have here on our flat. And it says a translation is a transformation in which each point of a figure moves the same distance in the same direction. So under definition here, okay, it's going to move, and we like to say a slide, because that's what it's doing. It's not picking up and going anywhere. It's just sliding from one place to the next. It's moving the same distance and same direction. That's my definition. It's a move or a slide that's the same distance and the same direction. Now, granted, if I see a graph, I can move that however many spots it wants me to, but sometimes they ask for coordinate notation, meaning without actually doing the movement, tell me what the coordinates would be. Okay, tell me what the coordinates would be. And so if you take a look at page 730, they show coordinate notation by saying x plus a, comma, y plus b. Now, A is my horizontal movement, left to right. And B is my vertical movement, up and down. Okay, So coordinate notation is x plus a, y plus b, meaning if I have horizontal movement, it's going to affect my x, and if I have vertical movement, it's going to affect my y. Okay, all right, so what does this mean in words? What does this mean in words? This means, let's write just what I just said, okay? X will move horizontally, meaning left and right. Let's go ahead and write out what that means. The Y will move up and down. Now you have to be careful here because if you were moving left, it would be a minus. If you're moving down, it would be a minus. So it's going to depend on which direction you're going. And if you want to use that plus or minus symbol, that's totally okay with me. All right, so let's do an example of this. And I'm going to have to use this whole piece. I'm going to use this too. Okay, so it says for my example, I have, and I'm going to use red and blue pins. So remember, blue is my original and red is my new. So my original points are 3, -4. Second here. And B is 3, 0. And C is 5, 2. So let's think about this. If it has 3 points, what shape would it be? A triangle. Okay? And then the transformation that they want is x minus 6, comma, y plus 2. X minus 6, y plus 2. So let's do our coordinate notation first. Let's grab our red pen. And remember, it's not A anymore. It's A prime. Sorry, I'm kind of blurry here. It's a little bit better. All right, so that means my x is going to get subtracted by 6, and my y is going to be added 2. So 3 minus 6 would be -3. -4 plus 2 would be -2. There's my new point. There's A prime. Now I'm going to do the same thing with the second part. 3 minus 6, this is B prime. 3 minus 6 is -3. 0 plus 2 is 2. And then for C prime, 5 minus 6 is -1. 2 plus 2 is 4. So those should be my new coordinates. Now, let's double check this. Let's work on my graph. Go ahead and draw in your coordinate plane. Oops. And go ahead and draw your original values with blue, okay? So we had 3, -4. And 3, 0. And 5, 2. What did I do wrong here?
We don't know.
Oh, shoot. 3, 1, 2, 3, 4. Sorry, ignore this point right here. Two. Use a ruler if you need to. So here's A, B, and C. Okay, now we're going to take all our points with our red pen. We're going to take all our points and we're going to move left 6 and up 2. And we're hopefully going to land on these spots. So if they don't, we've done something wrong, either with our coordinate notation or with our movement. Okay? All right, so let's start with A. A is supposed to move left 6 and up 2. And it's kind of hard to see on these graphs, so I apologize. 1, 2, 3, 4, 5, 6, up 2. There's A prime. Okay, now here's B. I'm supposed to move left 6 and up 2. 1, 2, 3, 4, 5, 6, and up 2. There's B prime. And then here's C. Again, move left 6 and up 2. 1, 2, 3, 4, 5, 6, up 2. It should look exactly like your original figure. It's just that it slid left 6 and up 2. So now let's check our coordinate notation. A prime is supposed to be at -3, -2. 1, 2, 3, down 2. Yes. B prime is supposed to be at -3, +2. 1, 2, 3, up 2. Yes. And then C prime is supposed to be at -1, 4. 1, 2, 3, 4. Okay. Okay. Now let's do another one of those. Go ahead and fold your foldable up, turn your page, go ahead and glue down 2 sets of graphs. We'll just go ahead and do 2 examples here. Okay. All right, so let's call this one example 2. We'll call this example 3. First coordinates here for example 2. This time we have J, remember we're in blue because that's our first color. J is -5, 0. K is -2, 0. L is 3, -4. And M is -2, -4. And my translation is x plus 7, y plus 4. X plus 7, y plus 4. So for J prime, I should be taking my x and adding 7, and my y and adding 4. -5 plus 7 is 2. 0 plus 4 is 4. K prime. -2 plus 7 is 5. 0 plus 4 is 4. L prime. 3 plus 7 is 10. -4 plus 4 is 0. And M prime. -2 plus 7 is 5. -4 plus 4 is 0. 4 points there. We could assume that this is some type of quadrilateral because 4 points means 4 angles, which means 4 sides. Now, let's go ahead and plot, and let's see that if we move it by hand, if we get these same primes. Okay, so go ahead and plot your original points. And like I said, I don't have enough hands to use a ruler, but I would appreciate if you guys would try to make yours as close as possible with a ruler. All right, so now I'm supposed to take all of my points and add 7, which means move right 7, and add 4, which means up 4. Okay, notice my X is my left and right movement, and my Y is my up and down movement. So here's J. I'm supposed to go right 7 and up 4. So there's J prime. If I check it, it's supposed to be 2, 4. It is. Now K, right 7, up 4. There's K prime. It's supposed to be 5, 4, and it is. Okay, now L, right 7, up 4. I'm going to move off of my graph, but it's okay. It's supposed to be at 10, 0, 9, 10. It is. And then M is supposed to move right 7 and up 4. It's supposed to be at 5, 0, and it is. And there's my new image. Okay, let's do one more of those. Let's do one more. Okay, we'll do another triangle. All right, so the triangle's vertices, which just means they're points. D is -1, -6. E is -2, 4. And F is 3, -2. My translation is supposed to be x minus 2, y minus 1. So remember what that means. That means I'm going to be going left 2 and down 1. All right, so let's start with D prime. X minus 2, so -1 minus 2 is -3. And y minus 1, so -6 minus 1 is -7. All right, E prime. -2 minus 2 is -4. 4 minus 1 is 3. And F prime, 3 minus 2 is 1. -2 minus 1 is -3. Now let's double check and make sure we're correct. Now guys, I'm highly knowledgeable in the fact that you could just plot all 6 of those points and say, oh yeah, that's what I got. That's fine, but you're never going to be able to double check yourself and make sure that you moved in the right direction. So that's why it's important to go back again, start from the beginning, plot your original points, do your movement, and make sure that you get those same values. So let's go back to our blue and plot our originals. Make sure you're using a straight edge or a ruler. All right, now let's apply our translation. So we are supposed to move left 2 and down 1. So here's D. I'm supposed to move left 2, down 1. Supposed to end at -3, -7. which I do. Okay, now let's go to E. Left 2, down 1. Supposed to end at -4, 3. Good. And then F. Left 2, down 1. Supposed to end at 1, -3, which I do. There's my image. All right, so that's when we have to do a lot of the work by our hand. Now, if you want to flip back, and if you want to look at the very first checkpoint that is in your book, the very first checkpoint says, describe the translation in your own words. Why that's so hard for that to see. Sorry, that's not focusing well. Remember, we go blue to red. So all you have to do here is you have to count, okay? How would I get from blue-red to red-red, or blue A to red A? I would have to move 1, 2, 3, 4, and down 1, 2, 3. So my coordinate notation would be X had to move right 4, so plus 4, and Y had to go down 3, so we subtract 3. Now it asks for me to do this in words, so underneath I would say move 4 right and down 3. So I have coordinate notation and I've also put it in words. It's an and sign. So let's look at number 2. Again, remember, we go blue to red. Sorry that's being so... Okay, blue to red. So just pick any of the vertices. So like I'm going to pick D here. And I'm going to count 1, 2, 3, 4, 5, 6, 7 that I had to go left. 1, 2, 3, 4 down. Whoops, let me count that again. 1, 2, 3, 4, 5, 6 left, and down 1, 2, 3, 4. So again, my X went left, so I'm subtracting 6, and my Y went down, so I'm subtracting 4. Then I can put it in words. Move left 6 and down 4. Now you can do it the other way around if you want. If you want to put it in words and then put it in coordinate notation, I'm fine with that. Okay, so that's just translating it in words, not having to do it yourself. All right, the last piece of this on page 731 talks about tessellations. Tessellations, it's on the bottom of page 730 and the top of page 731. And a tessellation is, if you look at your note-taking guide, we have a spot here for it. A tessellation is a covering of a plane with a repeating pattern of one or more shapes. So like a tile floor. If you were going to lay tile in your bathroom, you would want to make sure there weren't any gaps, okay? They lay down perfectly beside each other. That's a tessellation. It's a tessellation of a rectangle or a square over and over and over again. It's a covering of a plane with a repeating pattern of one or more shapes. A very popular artist named M.C. Escher did a lot of tessellations, and I have some here for you to show, or for you to look at. Here you can tell that the shape is an arrow, and they just go back and forth. They fit together perfectly. This one's a little more complex, we have kind of like a bird-like shape or like a half of a plus sign, and it goes on and on. Now they've changed the color to make it look a little prettier, okay? And then we have the birds. And this is what he was more popular for, is taking a shape and making it look like a fish or a bird or some sort of design. And as you can see, there's no gaps in between. Those are their beaks. Now, I also have some non-examples, some things that aren't tessellations. As you can tell, this pentagon is not a tessellation because I couldn't put another pentagon right here in this gap to continue this pattern. Same way with circles. If you put a bunch of circles together, you'll always have gaps in between. So that's another non-example of a tessellation. That's not a tessellation. Now this one's a little bit different. If you just look at the octagon, the purple itself, it's not a tessellation, okay? Because you can see these gaps right here. But if you think of this entire kind of like square-shaped region right here with the diamond in the middle, that tessellates over and over again. So that's what they were saying with it's a tessellation of more than one shape. If I take those octagons with a diamond in the middle, then I can repeat that pattern over and over and over again. There wouldn't be any gaps. Okay? All right. So in example 3, it asks, tell whether you can create a tessellation using only translations, meaning only sliding. I can't turn it. I can't change the shape. I'm only moving them over. And as you can see, A, tessellates. I can line those right up. But B, a pentagon, that's going to create a gap. And you're going to either have to draw that out to see it yourself, or you're going to have to be able to picture that in your mind. Okay? So that's the last part, tessellation. So homework for today. Homework for today is page 732, numbers 6 through 16 all. And you will need graph paper for this. So you can cut out and glue on here, or you can use the entire graph paper and glue the graph paper in, whichever you want. Remember, you can find this video on YouTube.